Hello students, welcome back. So now we are going to be focusing our attention on decision tree regressor. Decision tree, if you recall, these are your supervised machine learning algorithm and they can be used for both classification and also for regression. So the basic idea of decision tree regression is this. You split your data into regions and at the end you predict the average value per region. So let's say this is my original data right here. I split into this region, then I split this data into again let's say two regions, this one and this one. So let's say at the end I get this region, this and this. So my prediction let's say falls in this area right here. So my prediction is going to be the average value of this region. Likewise, the prediction, let's say if it falls over here, then you're going to try to predict the value as equal to the average value of this region. So let's understand this through a simple example. Suppose we are trying to predict a house price based on the size of the house, the number of rooms in the house, how old is the house, that will be your age of your house, and how far is the house from the city center. That's your distance from the city center. In this case, we are trying to predict the house price. So let's say the data is given to you like this: size, room, age, distance, and this is the column that we have to predict. So this would be a regression problem because we are trying to predict a numerical value, this number right here. Now, a few things you can note from our common day-to-day life experience. If you have a larger size of the house, the price of the house is going to be higher. That means this is going to be higher if the size is higher. Likewise, if you're less distance from the city center, in other words, you're closer to the city center, you are going to have a high price. Also, if your house is new, it's going to be a little bit more costly. In other words, it's going to have a high price. Here, you make a series of decision splits based on the features and also the feature value so that it gives you the maximum information gain. If you recall, I discussed this in my previous class, in my decision tree classifier. You can go ahead and watch that video and that will help you understand. So at the end, when you make this decision, your tree will look something like this. Now let's try to understand what each value means on these each node right here. This is my one node, this is another node, another node. So let's try to understand these values. Let's look at this one, sample. It is telling me that the number of samples you have is 8. Okay, so in the initially when you're starting this right here, you can see that the total number of samples you have 8, 0 to 7. Then it tells you the value. This value refers to the average value or average price of all 8 samples. So in other words, you take these numbers right here and you calculate the average of all these numbers. This will be your average price. That would be this one right here. Okay. And then you have this squared error. The squared error, it refers to the difference between your actual value and then your average value. And then you square them all together and you divide by 8. So in this case, let's look at the first one. The first one is 80. So it's going to be 80 minus the average value. The average value is 129. You can see that 129.3. So 80 minus 129.3 square plus the next value would be this one right here, 85. So it's going to be 85 minus 129.3 square. And likewise, you can keep going all the way at the end. That will be this 200. So it's going to be 200 minus 129.3 squared. And at the end, you divide by the total sample size. That's going to give you your squared error. This is how you get this squared error. And then we make a data split at the root node. And the condition we choose is size is less than 1350. That would be this right here. So we make the split and then you will have two types of data. You either if it satisfies the condition, that will be true, or if it does not, that will be false. So the data or the set of data points where your size is less than 1350 would be this right here. You can see that size is 800, 900, 1000, 1100 and 1200. Now in this particular instance, you can see that the number of sample is 5. 1, 2, 3, 4, 5. This is what this refers to, the number of samples. And then you have the average, that's this value 101. That would refer to the average price of this one. So you're basically taking the average price of all these data and that'll give you 101. Then you have this squared error. This squared error, it means the same thing as in the previous one. So you're going to take 80 minus 101. In this case, 80 would be this right here. And your average value of this particular data set is 101. So 80 minus 101 square plus 85 minus 101. 85 would be this one right here. Minus 101 square, and you keep going all the way to the 130. That would be this right here. Minus 101 square, and then divide by the total number of data points. In this case, there are 5 data points. 1, 2, 3, 4, 5. On the other hand, if this condition does not get satisfied, this one right here, then your data gets split into this part right here. You can see that over here, your size is 1500, 160, 1700. So all this thing is greater than 1350. So now you have two splits, split 1 and split 2. And then we make another split. This time we do split at the node where its size is less than 1050. So let's say we go on this one right here. So in this particular instance, when we make a split, you're going to see that you will have two splits, if it's true or if it's false. True means that the size is less than 1050. You can see that in this particular instance, you will have three samples. So you have 800, 900, 1000, and you can see that in this particular instance, your size is less than 1050. Also, if it's false, that would be this condition. So in that particular instance, you can see that your size is more than 1050, all of these numbers right here. Likewise, then you have this number of samples. In this case, is 3. So that's why this is showing 3 right here. And then the value is 85. That would be the average value of these numbers. That's your 85. That's what this number is. And likewise, same thing with these one. Samples in this case is 2. That's why you see 2 samples. So this is what's happening when each node over here is making these splits, and based on the splits, actually splitting your data. And now let's look at the data split at the node distance less than 9.5. That would be this one right here. So in this case, oops, let me just, yeah, that would be this one right here. So in this particular instance, you can see that if it's true, then the number of samples would be equal to 1. And you can see that the number of samples is exactly 1. And the average value is 90 because there is only one data point. And squared error is going to be 0 because 90 minus 90 squared divided by 1 is 0. So this is what you get with this final. So in this case, I showed you how you go this route, and then you come this way, and then you make this way. And likewise, you can go all the different routes over here, and you can find different data points. So now suppose you're given the task to make a prediction of a house price, this one right here. So let's say somebody says, hey, predict me the house price of a house that has a size 1400, number of room it has 3, and the age of the house is 6, and the distance it is from the city is 5. So the first thing you do, you ask this question: is the size of the house smaller than or equal to 1350? In this case, that's not true. That's false. So you're going to come in this route right here. Then you ask this question: is the age of the house smaller than or equal to 4.0? Well, the answer is either going to be yes and no. Again, you look at your data. So in this case, age, you can see that your age is 6. So in this case, it is not true. So you're going to come in this direction, false. All right, then you ask this question: is the distance less than or equal to 3.5? But when you look at the distance, it is 5. So in this case, this is not true. That means you're going to come in this direction. And then you reach the final node right here. You cannot go any further. Since you cannot go any further, you calculate the average of the number of samples, and you look at the number of samples and you calculate the average price of those samples. And the answer will come out to be 160. So the average price of this particular sample, that would be this sample, the answer is 160. Now this decision tree I just created can be done very easily in Python. So the first thing you do is import your pandas, import your NumPy, also import your decision tree regressor, and this is the one that's responsible for plotting your tree. So this is my data. The data I just created is basically a small data just to explain you. So in this case, this is my size, room, age, distance, price. So this is my data frame right here. Next step, I'm actually separating my features X and also my target value Y. So this whole thing would be my X right here, from here all the way up to here. So this is my X, and this part is my Y. This is my target variable. So that's what I'm doing over here. Then I'm actually picking up a model. In this case, I'm using decision tree regressor. I'm picking maximum depth, like how deep I want to go in my decision tree. So I'm going to pick up only 3 in this case. Random state, I'm 42. I'm training the model right here. And then coming down, then I predict the house price of a, let's say, new house. Let's say somebody gives you, this is the size of the house, this is the rooms, number of rooms, so size, rooms, age, distance. They give you these values. So the age of the house is, let's say, 6 years, and the distance from the city is, let's say, 5 years. They want you to predict the price of the house. So you convert your data into a data frame. That's what I'm doing over here. I'm asking the model to make a prediction, and then it makes a prediction, and I print out the value, and the answer comes out to be 160. And then I use this code to plot the tree. So I'm specifying my figure size. I'm calling the inbuilt method plot tree right here. Specify your model, specify your feature names, filled equal to true, rounded equal to true. You want your numbers to be rounded, and ask it to show. And then at the end, it renders your graph. So this is how I came with that particular diagram. So, what are the advantages of decision tree regressor? Well, number one, no scaling needed. You saw that. I worked on straight on the raw data. I did not perform any type of scaling. Also, it can perform non-linear learning. What it means is that it can capture very complex patterns. Also, it's easy to interpret. What it means is that you're using rule-based system. So this way, you can explain to somebody. You can say, if this condition is satisfied, you actually took this data set. If this condition is not satisfied, then you went that route. So basically, series of yes and no rules right here. Also, it can handle mixed features. So if you have columns that are numerical or categorical and mixed together, it can handle both things pretty effectively. So some of the use cases of decision tree would be in your real estate pricing and also for risk modeling.